In this video, I'm going to introduce limits and types of discontinuity. So first of all, let's talk about the limit. As you have seen this picture before on the cover page of the packet, take it to the limit. So what is limit is? We write instead of limit, we just write LIM, X arrow C. What that means is X get closer and closer to the C. F of X is a Y value. My graph gets closer and closer to the L. So X goes to some C value, Y value goes to the L. And let's take a look at the formal definition in your packet. And X in the words, what I showed you in the picture, this is in a words, that X get closer and closer to some number C. Y value of the function f get closer and closer to some number L, and then we say that. How do we say it? You have to know how to say the correct way also. The limit as x approaches C, y value or f of x is equal to L. So for example, giving you in a graph point of view, let's say this is the C. Function value get closer and closer to the C. Like if you are coming closer and closer to the C, this number is a L. L is a Y value, C is a X value. X get closer and closer to the C. What is the Y value? Okay, so before we go into finding the actual values, we have to know that the limit from the left and limit from the right. So what is a one-sided limit? So again, I'm going to use the same picture again. Let's talk about here. I'm going to use the same picture. This is the C. X left hand limit is X approaches C from the left side. So for example, graph is going from the left side somewhere. What this Y number is L. So X goes from the left side. Now from the right side is the same C value, but I'm coming from the right side, coming at the same number. So from the left, from the right. If it is the same number, then we can say that limit exists and that number is a L. If they are different, limit from the left and limit from the right is different, then we can say limit does not exist. So for example, again, if I'm coming from the left at this point and right, I'm different point. These two numbers are different, then we can say limit does not exist. Okay, so then possibility, there are three different types. This is one, both sides same. You come at the different point. And the third one is it's possible that you go to the infinity. In other words, vertical asymptote. So for example, this one is if we visualize the graph x from the both sides, you are going to the infinity. That is the vertical asymptote and you are going to infinity. So x approaches C, my y value goes to infinity. You can see that that's a negative infinity. So what means this is the vertical asymptote, y value, both sides you go, there is a vertical asymptote at C. Again, they both are vertical asymptote at x equal to C, but this is the limit notation. Okay, so limit x approaches CF of x is sometimes called two-sided limit to distinguish it from the one-sided, left-sided. Now, I also teach a calculus, and so far we have never used the word two-sided. If it's same, both side is the same, then we call limit exists. So let's take a look at this example here. If limit from the left is C, L, limit from the right is L. If the same number, then if we don't write plus or minus, we can say it is L. So limit exists. It exists. If the both sides come at the same point, then limit exists. Now let's take a look at the three different types of discontinuity on the other side. Okay, so discontinuity itself tells you that the function is not continuous. What's the definition of continuous function? If you can sketch without lifting a pencil, it's called continuous function, obviously. Functions that have a break in the graph are called discontinuous function. There are three different types of discontinuity. You must know the name of them, you must know how to find them, and you must know how to sketch them. So the first one is called removable discontinuity. In other words, there is another name for this is called point discontinuity. Okay, so let's understand the limit statement. Limit x approaches a from the left. I'm coming from the left. What is the y value? Here in the graph, the y value is not given, so let's assume that the y value is negative 1. So what's this answer? Limit x approaches a from the left, y is negative 1. Okay, now limit x approaches a from the positive side. I'm coming from closer and closer and closer to the a. What's that? Y value is also negative 1. Is function defined at a? Not defined because there is a hole. You can say that there is a open circle. Open circle means not defined. So what is the limit x approaches a if there is no plus or minus? What do we write here? Because these two numbers are same, we say limit from the left, limit from the right is the same number. So these two numbers are same, so this is also same. Okay, so understand this whole concept again. There is a hole at x equal to a, means function is not defined, but limit exists because you are coming from the both side at the same number. Limit exists. Limit exists and answer is negative 1. This is called removable discontinuity. Why removable? You can fill in the hole and you can remove. So that's why we call removable discontinuity. Okay, so let's take a look at the second type. It's called jump discontinuity. Clearly, you can see that if I sketch, I have to jump. Very popular, very easy. So let's talk about limit x approaches a from the left. I'm coming closer and closer. Basically, you trace the graph towards the a. What is the y value? Y value is 0. If I'm tracing this graph closer and towards the a, what is the y value? So let's say y value is a 2. I mean, it's not given here, so we can say 2. What is f of a? Where is a closed circle? F of a is a 0 or f of a is a 2? Here, f of a is a 2 because that's where is a closed circle. So if I write here this limit x approaches a, no left or right from both sides, what should be this answer? 0 and 2 are not the same number. So this kind of limit does not exist. D and E is a very popular acronym. Does not exist. Limit does not exist because from the left and from the right you are coming at the two different places. So limit does not exist. Is function value defined? Yes. F of A is a 2 because there is a closed circle at 2. Jump discontinuity is also called non-removable. You cannot remove this discontinuity because it's not easy to fill up the gap. It's easy to fill up the hole, but you cannot fill the valley. It's a huge gap. Third type of discontinuity is called infinite discontinuity, which has a vertical asymptote. So this is easy to spot. Wherever there is a vertical asymptote is infinite. This is also called non-removable because you cannot remove the asymptote. Sometimes students use the word jump discontinuity, which is not true. Jump is for smaller jump. You cannot jump from negative infinity to positive infinity. So here, this kind, let's understand again. X approaches a from the left. I'm coming closer and closer from the left. Where am I going? Negative infinity. X approaches a from the right side. where you are going infinity. Is function value is defined? Not defined. You can also write does not exist here, not defined. And since these two numbers are different, you can say limit x approaches f of x does not exist. Now notice here, if they both are positive infinity, then you can write positive infinity. If they both are negative infinity, you can write negative infinity. But since they are different, we write does not exist. So three different types of discontinuity from the graph. Okay, so now let's try to answer these questions here. So you are given the graph, x approaches negative 2. So find out where is negative 2 is here. There is a vertical asymptote at negative 2. So what type of discontinuity is this? Infinite discontinuity. X approaches negative 2 from the left side of the negative 2 is here. I'm going closer and closer to infinity, coming negative 2. So you have to go very close to the negative 2 is negative infinity. F of negative 2 is not defined, and this is infinite discontinuity. Now let's take a look at negative 1. So negative 1 is here. Okay, so I'm using a highlighter to understand. X approaches 1 from the left, which means 1 from the left. What's the y value? Y value is negative 2. X approaches negative 1 from the right side. So that is from the right side. Y value is negative 2. Is f of negative 1 is defined? Not defined. This is a point discontinuity, or you can say removable. Now let's talk about this answer. If limit x approaches negative 1, not left or right, this limit is negative 2 because these two numbers are same. Here, if I say limit x approaches negative 2, f of x does not exist because these two numbers are different. I mean, infinity is not a number, but they both are different answer. And one more here, x approaches negative 2. I'm coming closer and closer to the negative 2. This number is a 2. And I'm coming closer and closer from the right side. That number is a 4. This is a jump discontinuity because you are different numbers. F of negative 2 is a 2 because of the closed circle. And this limit without left or right, since the numbers are different, we say it does not exist. So three different types of discontinuity. Again, on this page, you can see this is infinite, this is a point or removable, and the jump, another name for the jump is non-removable. It's easy to look at from the graph. Sometimes you have to see the statement and sketch the graph. So let's take a look at this page, next page. Okay, so you don't have the graph, but you can easily sketch the graph based on this information. So level each type of discontinuity. So if you are coming to from the left is, you are coming from the left at 4. You are coming from the right is a 9. Obviously, this is a jump discontinuity. What could be f of 2? Now, this is open-ended question. F of 2 could be 4 or 9 or any other number. It could be any other number. It could be any other number. It is possible that they both are open circle and the circle is closed here. It is possible. So it could be any number. There are so many possibilities. It could be 4, it could be 9, or it could be any other number, or it is also possible they are not defined. It's also possible not defined. These are all possible answer. It cannot be both, otherwise it's not a function. Okay, so let's talk about this here. X approaches -3. You see here, you should be able to visualize that there is something happening at -3. You coming from the left side, you are going to infinity. You coming from the right side, also you are going to infinity. So this is infinite discontinuity. And you can say f of -3 does not exist because the both sides you go to infinity. In other words, there is a vertical asymptote at x equal to -3. Okay, clearly the both numbers are same. So you are coming at 1 from the left, 1 from the right. Both numbers are 2, -2. But f of 1 does not exist. That means there is a hole. And this is called point discontinuity, or you can say removable discontinuity. One more time, jump, infinite, point based on these limit statements. You should be able to sketch the graph. Let's take a look at a couple of examples here. A quick graph is given. You answer the question. To understand, we give you ready statement. You just have to read the graph. So I'm just going to do one example with you here. X approaches 2 from the left. That means from the left, number is 3. 2 from the right, number is 1. Are these two same? No. That means this does not exist. This limit does not exist. This limit does not exist. But if I ask what is f of 2, for that part you must look at the closed circle. What value does it have a closed circle? And f of 2 is 1. This is the jump discontinuity. Practice some more here. X approaches 3 from the left is a 2. 3 from the right is a 4. This limit does not exist, and I'm purposely putting f of 3 is a wherever there is a closed circle. This is very interesting one. Let's watch about this. 3 from the left, 3 from the right. All the answers are 4. These two numbers are same. So that's also 4. But what is f of 3? F of 3 is 1. This is a point discontinuity, jump discontinuity. And we have one more here. 1 from the left is a 1. 1 from the right is a 3. These numbers are not same, does not exist. And f of 1 is a 2.